All right, good afternoon. My name is Jason Feist. I work at Seagate Technologies in the CTO office, and excited to be with you today talking about experiencing data together. I'm going to give you a little overview of how we participate with the open source community, specifically OCP, and share with you some of the exciting technology advancements we're working on as a company. So was super excited to see the keynote from Kshagra this morning, where he cited some of the work that we did with IDC in terms of looking at how big the actual storage ecosystem is, the Datasphere, as that paper called it. It's an exciting time in the sense that we who've been in the storage industry for a long time have seen things go up and down over time, change platforms. But one thing that's persisted is people need to store data and they want to store more and more of it. And all these new devices coming online is just creating a massive influx that's going to take advantage of all the expertise we have in the enterprise data center. We're seeing, an expected 80% of the data that's created is going to be stored on enterprise bytes. So with that requires a lot of innovation between all the companies that are members here in OCP to be able to manage that. That's a drastic change from where we've been. We've gone through cycles where it used to be everything was created in a client kind of device. Now it's shifting back towards we've got a mobile cloud world, and the enterprises, on-prem, public cloud, private cloud, are now where all of these bytes are ending up in their final resting place. So as we move forward, I think the chart on the right here is what's most disruptive. We see the world revolving around a data center. It's growing rapidly. It has massive scale. It has economies that just create innovation, opportunity, and areas for excellence. And from that, we're trying to figure out how do we take those successful wins in terms of data storage, data movement, data flow, and propagate them out to edge use cases. We're going to see things near points of access like cell towers. We're going to see things at central offices. We're going to see things at gateways that are now going to require data storage and data movement. And that's where all of our learning inside of the data center business can be applied and expanded to help those markets grow and take advantage of the economies of scale. And beyond that, it's going to go out all the way to the end user. We expect that devices themselves, the endpoints, are going to be intelligent devices. There's going to have to be inference. There's going to have to be decision making. And ultimately, that will be a funnel for this 175 zettabytes of data that is going to be moving around the Datasphere and ending up on storage devices. The other cool part is no one single media type can solve this problem, right? We talked about supply chain. We talked about the overall ecosystem of bit generation. So what's exciting there is from the study, it was clear to us that the ecosystem as a whole is very healthy, right? There's a massive need for HDD storage. There's a massive need for solid state storage. We have optical storage and tape. And with that, that all plays very nicely into the community. OCP has done a phenomenal job of creating a storage track where all of these media types can get together and solve the problem at the right point and really talk and communicate about what are the requirements that are needed at each one of those tiers. Each one of those industries is creating bits at different rates, which means their ability to keep up with that growth is going to require different levels of interaction between the suppliers themselves and the customers that are consuming this storage. Some really interesting breakthroughs in how fast we've been able to keep this CAGR moving. And we see lines of sight with all of the media technology and head technology that we're going through to take us all the way up to that 10 terabits per square inch down the road. So what I think is great in terms of the community, right now we have the storage call. We've expanded that this year and we've got the OCP archive call. That's allowed us to talk about how do we retain and store all the bits. Our goal, if any of you came to the talk last year, was we want to remove the delete key, right? We want to make sure you have the ability and the infrastructure to be able to consume and store all of the information your applications desire. So I think we've created good communities around those two topics. We've started with the data security flow down to the devices and how we will interact with those data security features and root of trust implementations that are being created on the PCIe bus. And what we still need is more collaboration and discussion around interface, connectivity, and data flow. So in terms of experience data together, Seagate brings to this table, 3 areas of excellence. So device physics is our bread and butter. Our R&D infrastructure is focused on enabling data center growth through slot and rack density. We want to ensure that you can get access to that data and have the right level of I/O per terabyte and tiering capability to let the data flow through its data gravity. We definitely care most about durability and resiliency to ensure that the data you put on our storage devices is forever maintained and secure. And we want to do so in a sense that we do it with a power optimization in mind. We understand the energy costs, and we understand how many spindles and devices are actually deployed in these large facilities, and we know what a large burden that is, and it's a continuous burden for the entire service life of a drive. So we want to continue to look at ways to optimize that with the customers and manage it and use the power appropriately. Some of the areas that we'd like to continue to explore in the upcoming year is really around data flow and data management. Connectivity. We've had the SATA interface for many, many, many years, right? We've also had the SAS interface for a long time. There's a lot of innovation and excellence around NVMe at this point, and we've brought to the OCP face-to-face and working groups discussions around how do we as a community define what that connection point should look like for data storage. And then subsequently drive the standards out of that to set the right command sets in place and to ensure that the APIs that are needed for interaction are appropriately placed in open source communities. And last but not least is, with all of that, I think everybody can look at the news on a daily basis and know that data security is of the utmost importance. So we continue to employ and innovate around data security technologies, things that keep your data at rest secure, such as SED, self-encrypting drives, instant secure erase, so that you can ensure that the data is removed fully. We continue to accelerate technologies like attestation to ensure you have the ability to sign your firmware and know where it came from and communicate appropriately, and as well as do secure downloads around that. We're looking at opportunities around furthering the strength of the supply chain itself through technologies like provenance and blockchain, and exciting developments will be coming there over the year. Let's dig into some of the specifics. So with respect to how do we improve rack density and slot density, first and foremost, this is our core IP that we spend our research team's blood, sweat, and tears on trying to figure out how to get the most density out of a device. We continue to innovate and develop and productize HAMR technology. We have proof of existence of that technology being able to write over 4 petabytes of data. We've shipped our first drives to key partners in the industry already, and we're still on track for producing 20 terabyte plus drives in 2020. We want to continue to work with the industry in terms of how these drives will be deployed now that we have such large magnitude of capacity on a single spindle. And we want to ensure that the drop-in replacement technology is really there. There's no change in the behavior of the temperature. There's no change in how you're going to have to access the drive and interact with it, as proven by some of our key partner deployments that we've undergone. And just for awareness, on the right side, I've published some demonstrations of actual hammer heads and spin stands and areal density demonstrations that we're making, as well as level setting people on how much do hard drives actually write. So these devices have many heads inside of them today. 16 or 18 head devices are pretty common in the marketplace. And when you think about using that device over a 5-year service life, we would expect each one of those heads to write somewhere between 150 and 170 terabytes a year, 170 terabytes per head in that 5 years. So when you think about what we've done in terms of our component demonstrations and early drive demonstrations, being able to show that the technology is capable of writing 4 petabytes, we're very confident that we can move this technology forward and solve these density problems for the industry. Along with that, our full portfolio of devices is, HDD and SSD. So what we're continuing to do is look at, as you again heard in the keynote, areas of how we can apply compression technology to enable NAND improvements and NAND utilization moving forward. We want to make sure that we can enable thin provisioning there as well to make sure that that storage capacity can be fully utilized. And in terms of standardization, we're an active participant inside of the form factor discussions and all of the standards bodies to ensure that this plethora of form factors that is out there today around SSD gets to a place that can be usable in the community. And we decide upon where we're going to go and what we'll productize and develop. We see a clear path in terms of density on the NAND, just like we do on disk. We definitely see a path to 1 terabit die and QLC NAND driving new applications, new use cases, and new optimizations. And in couple with that, our storage technology on disk, we believe we're in a unique position to present both technologies, their capabilities, their strengths, and their weaknesses, and really act as a storage consultant for questions and pain points that you're trying to solve as a customer. Once you have a lot of capacity on your device, now you need to figure out, okay, at what data flow do I need to get the information off? So with a lot of the compression discussion in the keynote today, we heard talks of bandwidth, throughput, and then also we know that there's a lot of access density that's required to each of these device types. We presented this last year as a technology. We're excited to say that this will be brought to production in the community this year, our dual actuator technology. We've got a SAS device that's created 2 LUNs and essentially created 2 drives in every slot. A great improvement in the power profile. If you have a fixed performance requirement that you need from your disk, you're now able to solve that problem with significantly less power than using multiple disk drives to attack it. We're focused on improving that sequential I/O, so big block, big transfer size, data throughput, as well as small queue depth, random access to the disk. We believe a lot of the cloud applications and file system use cases are really optimizing around large block, sequential write and read, as well as short block, random read access to a disk storage tier. We've created an overall roadmap of capability to ensure that we can meet this I/O per terabyte need that the cloud sees for the foreseeable future, all the way out to 30 and 40 plus terabyte disk drives. In complement to that, we realized that not all data resides on disk. There are applications that need higher performance than that, and hence our focus and leverage between skill sets and capabilities of that data flow optimization. Within NAND, we see a lot of fast NAND driving latency optimizations. We see a lot of innovation within storage class memories on the architecture and tiering expectations. We're putting concerted effort to understand that data movement so that we can make sure devices at each tier are optimized from a cost and performance point of view. What's key here with respect to the quality of service is really about how we engage into the community and make sure that people know how to access into these devices to have good I/O determinism, to optimize the overall transfer to the devices and minimize write amp, as well as placing the data appropriately with things like streams. On top of that, our data recovery techniques are best in class, and we believe that this is one of the things that helps us avoid some of the rebuild access problems as now SSD devices are going to get bigger and bigger over time, which is again areas we want to continue to collaborate through the storage track of OCP. Okay, and last but not least on the technology side, all of this information is stored and moving around, and with that, we see a very, very strong security attach rate increase over time. We've been watching a 30% year-over-year growth. We've also seen that this is not specific to just one industry. We're seeing this in OEM, we're seeing this in surveillance, we're seeing this in NAS, we're seeing this in the cloud. This is a very common theme to deployment, and we know that it's a critical enabling technology for the end user to have their data secure on the drive. We know a lot of new regulation is in place, things like GDPR, that's requiring the data management to be secure. There's HIPAA compliance that's also very critical to ensure that data security. And so our areas of focus are really going to continue to be around data at rest and data movement, as well as supply chain verification to ensure that you can commit to all of your customers, a guaranteed SLA, a secure SLA, as well as a secure supply chain. Now let's talk a little bit about how we as a company are going to go embrace that open source API approach. Our three goals really are to ensure that the maximum capacity is deployed so that you can optimize your storage economics. We're going to make sure that all of our devices are optimal with respect to latency to meet the SLA requirements presented. And then we want to ensure you have data protection and compliance to meet those regulations. So that's the governing principles, if you will. And within that, we want to make sure you have access at the device or system level, how you choose to integrate storage into your ecosystem and allow features that can do the appropriate things for you. Not everybody has, a huge team of software developers underneath their belt, and so we want to make sure we're actively contributing information on how to take advantage of these technologies that we're enabling for large deployments all the time. We want to make sure that people can access the healing aspects so that if they need no-touch storage, they can have it. We want to make sure that those I/O deterministic functions and quality of service metrics can be met through command set abstractions. We also want to make sure that, if there are things that you want to do from a key management, security, protocol point of view, that we enable you through APIs and software into our devices to deploy this technology. I want to also include a real-world use case. So Seagate as a company lives and breathes the creation of storage devices. We also consume them and create lots of data within our factories, and we're trying to understand how the data movement, the data flow is creating bottlenecks and constraints. So what I've shown here pictorially is just an example, right? We make 1 billion transducers a year, which is our recording head device. Each one of those wafers that you see on the chart there in the yellow, we've got 100,000 sliders on each one of those platforms, and we've got real-time data moving through our factory from hundreds of tools that's online. And an example is we've got 17 million electron microscope images of that technology every single day. You could see how that creates a unique scenario, and you can't move that amount of data through your network continuously every day. You need to be able to solve some of these problems right there at point of entry, point of storage. And with that, all the machine learning and artificial intelligence algorithms that are being developed in these platforms, we need to take advantage of that and figure out how can we appropriately place the storage in that ecosystem to enable that analysis. So this has been a great eye-opening experience for us that we think a lot of other companies are dealing with on a daily basis. And we want to try to ultimately wrap this up and create reference architecture designs that we can then share back to the industry and community of, hey, we too are dealing with problems like everybody else, and here's how you can manage them and solve them with storage systems in mind. And then on my last slide here, I think the key piece that I want everybody to leave with today is that at the root of all of this is, core device physics, core data flow, data movement, data creation, and data security. That is the ecosystem in which we live, and we believe that the endpoints are creating a lot of content, and that data has to move somehow, whether it be through a shuttle to an edge ultimately to a private or public cloud. But it's going to be really important that we understand that life cycle of data, we understand who has access to it, and we understand how we can optimize at each one of those touch points the appropriate storage economics and storage quality of service metrics. So you'll see a lot of focus from us on how to do this simply, how to do it securely, and how to do it with high resiliency. So I'll just leave a tag here at the end of the presentation. We're going to have an additional talk about our open source contributions of the tools that we have to manage data and interact with the devices themselves. Mohammed will be giving that talk in the expo hall later today. I encourage you to stop by and see that, as well as check out our open source tools that are on GitHub today. Okay, that's all I have for today. Thank you very much.